First, thanks for having me. Any of you who've been to my talks in the past? Raise your hand. Oh, yes. Okay, some of you, and some have not. So this is more or less an interactive talk, which means if you've got a question, ask me when it pops up. Okay, so don't just stop me for a second. If it's relevant, I'll answer immediately. If not, we'll wait to the end. Okay. So I'm going to talk about scaling voice over IP networks in the cloud. Specifically in our case, I'm going to talk about Amazon, because Amazon is an interesting case into how you build voice over IP platforms in clouds. How many of you are familiar with CloudFormation? Oh, very good. I got a good crowd. Yes, nobody knows about it. Great. Okay, so as I said, my name is Nir. I've been an open source voice over IP advocate since about 2002, when I got more or less fed up with Panasonic, where my PBX got every 2 days. And then I moved on to Asterisk and so on. I'm the creator of PHP ARI, if anybody is familiar with that. It's a toolkit for developing ARI applications. Father of two, would-be amateur chef, I wish, and all-around Uber geek, which means that you can talk to me about anything that has to do with voice over IP, clouds, or if you want to talk about bicycle riding, that's fine as well. So what do we do exactly at Greenfield? We see ourselves as innovators, and the idea is that we create dreams, we create things that don't really exist. People come up to us with the most outrageous things with the question, can that be done? And the normal answer will be, let's think about it for a day or two and we'll come back with an answer. Normally the answer is yes. And we'll just speak out and say, yes, this is doable, this is not doable, whether you like it or not. So let's talk about some traditional challenges. In the traditional world, anybody remember what it was to install like real platforms, what it felt like? Physical platforms? Who's still doing that? Raise your hand. Who's still using physical servers? I'm sorry. So first of all, we have the sourcing of the hardware. This is actually the back of my car 5 years ago. Really, I do own these servers. They're a piece of shit. I mean it. And sourcing can take a while, depending if you buy refurbished or new equipment. It will always take either a few days, if you're lucky, or a few weeks, if you're really lucky. That means that you got good stuff. Then you need to install it. Whose data center looks like this? It used to. I don't own it anymore. Yeah, it's kind of annoying. I remember back in 2002, I was working for this startup, and we had a server's room in our company that spans 8 racks. We had over 15,000 Ethernet connections in there, out of which I guess 99% were not active. We just couldn't take them apart. And of course, configuring everything. This, more or less, this is not my table. I don't think I want this kind of table, but this is more or less what I saw in one of Vodafone's NOCs as somebody's table, which was kind of ridiculous when you think about it. And of course, we pray to God that it actually works, because somewhere somebody misconfigured an IP number, right? This is what happens. And when you think about it, so we fast forward 10 years into the future. Now it's 2017, and we've got Captain Cloud or Captain Infrastructure sitting in our midst saying, no, 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 you should use the following, guys. We've got Amazon, we got Microsoft Azure, we've got Google Cloud, DigitalOcean, Voltaire. Have I covered more or less all of your options right now? There are a few others, but okay, who uses Amazon around here? AWS, hands up. Google Cloud. Azure. Very few people using Azure. Why? Because it's Microsoft. Good one. Yeah, okay, we'll grant you that. Who uses DigitalOcean? This is an interesting question. And Voltaire, anybody know about Voltaire? Oh, very few. Okay, so Voltaire and DigitalOcean are more or less the same thing. So, word of warning, we're going to get extremely technical now. And that means that unlike previous presentations where a lot of the speakers talk about features and stuff, I'm going to actually show you code and how things are being done. And I'm going to talk about 2 of our open source projects, which were released a couple of months ago and are very interesting, specifically for working on Amazon. So more or less, this is how a normal VPC would look. So we got our public signaling, media services, public portal, various internal microservices that we use. You can use Java, Ruby, Node, Python, PHP, Go, whatever you want. Anybody write in Erlang? I'm sorry. Okay, and of course your databases. So we got your Dynamo, your MySQLs, your NoSQLs. Take your pick. Build your stack from whatever you want. I don't care what your stack looks like because it doesn't really matter. At the end of the day, clouds, and this is the main thing here, clouds are not virtual servers. They're not just instances, and this is the primary mistake that 99% of people who use clouds do. So if you go into somebody and ask them, hey, what is Amazon Web Service? What is AWS? Oh, it's an EC2 instance. Oh, it's a cloud container. Oh, we've got some funky stuff running with Docker for microservices. Great, awesome, but it doesn't mean that you really utilize it to what it's worth. So we ended up in this situation when we've the community, the tech world, invented the microservice infrastructure. So we have a lot of microservices doing bits and pieces of everything, but we're actually the microarchitectures. We're the microinfrastructures that we need to build in order to actually scale things the right way. Nobody gave it really any thought, because in order to create a microinfrastructure, you need 4 elements. You need, first of all, you need compartmenting. And that means the ability to go about and take specific services or specific infrastructures and build them into its own compartment that can scale on its own. Second is orchestration. This is more or less our DevOps. No, I'm kidding. We don't have any DevOps. All our developers are DevOps because there is no difference between dev and ops today. In the cloud, DevOps is dev and dev is ops. Forget it. Don't have 2 teams. It's the same thing. Oh, by the way, if you've got a dev that doesn't understand ops, he should see the boot. Really. Command and control, analytics and auditing. So these are your 4, let's say, zones of interaction with your platform. I'm not going to talk about these. And there's a reason why I'm not going to talk about it, because they're not interesting at this point. They have nothing to do with scalability, and they're mostly related to your business model. So we're going to talk about, first of all, compartmenting. Made up of 3 distinct steps. Identify your service operational zones. Identify the scalability paradigm for that zone. Compartment each zone into a logical unit. So what does that mean? So each of the highlighted zones is its own zone, and we have to cater for scalability in that zone on its own. Media services require scalability in one area, and it has to be done one way. Microservices a different way, and so on. And it continues from there onwards. So in order to do that, first of all, if any of you are still using, anybody still uses IP numbers in their platforms, like static IP configurations, raise your hand. Stop doing it. It's stupid. It's stupid, it's redundant, and it makes your life a living hell. Because, oh, I forgot that IP. Crap. Oh, the firewall is not configured right. Oh, what was that name again? Oh, I have no idea where that server is. And DNS is your friend. Use DNS. Stop using IP numbers. In addition, in cloud infrastructure, IP numbers have no meaning whatsoever, because you terminate an instance and that IP number is gone. It's dead. So what, you're gonna go over like 100 instances and change all your IP numbers again? And do it 3 times a day? And while in deployment, you're gonna do it 16 times a day. That's kind of annoying, isn't it? Databases are your enemy. Now everybody says, oh, let's store the configuration inside an RDBMS. Who stores their configurations inside an RDBMS? How many of you? Raise your hands in shame. Yes. Why is that bad? Can anybody tell me why is that bad? Because it's the same like using IP numbers. First of all, everything is located in one place. everything is static, it's very much like having your own configuration files. So in order to create these relations between our servers that should be there, we need a different paradigm to go about and be able to tell our cloud, yes, you're part of this entire infrastructure and you're allowed to talk to each other without using that RDBMS. It's just pointless. And the worst thing about RDBMS is that scalability has kind of like a glass ceiling on top of you. Because at some point, your platform is either too big to sustain the number of requests. I met, so I was at IT Expo in February, and I met this person who was so proud of themselves that their Oracle cluster spans 150 nodes, totaling at over 168 terabytes of active RAM. And I'm going, okay, so what do you do with that? And he goes, number portability. What? Okay, dude, like, fine. Number two, peer-to-peer security is bad. What does that mean? So we're very much accustomed within our platforms to actually configure relations between gateways and signaling environments, saying that IP is well known to that IP, and I'm willing to let them communicate directly without any type of authentication. But in order to do that, I need to statically configure them somewhere. So it's back either to the RDBMS or a static configuration file. But still, that is not scalable, because with any new host that you put into the platform, let's go everywhere and start configuring. So what most people will say, oh, that's an interesting thing. We have orchestration to that. So we're going to talk about orchestration in a few minutes. So try to rethink of how you tie the various elements in your platform to communicate in something more of a PKI method. So they will identify themselves between themselves and understand that they are who they are. Orchestration works more or less like this. Your network should be fully automated. This is what we strive for. So whose network is fully automated? Nobody picks up their hand. I wonder whose network has auto-scaling media services? One person, two, three people in a crowd of 120, more or less. You should use Cloud Init. That means that your infrastructure can dictate how you do your scaling, depending on the cloud that you're going to use, and I'm going to basically explain according to Amazon. And then, of course, the ever-dreaded code, deploy, test, repeat, because this is what we do. And you're going to break things. So Amazon has this amazing tool called CloudFormation. Anybody used ever CloudFormation? One person in the back. Just one person in the entire room. I bow before you. How many templates do you have? 5 templates. Okay, maybe I can help you with that. Okay, so CloudFormation is basically Amazon's language of describing your overall stack. You can have multiple formations and multiple stacks in your account, and your stack is kind of like your description of what you're doing. According to Amazon, everything has to be in one, either JSON or YAML file, which more or less looks like this. Oh, great. Okay, I won't do that now. But in fact, according to Amazon, you need just one YAML file to describe your entire stack. Now, if that stack spans like 7, 8, 9, 10 different networks, 50 different servers, 16 different auto-scaling group, that will be a file that is about 50,000 lines long. And anybody remember the good old days of, the good old days of writing asterisk dial plans that were enormous? It looks more or less like that. So I'm going to try and hook up again. The beach ball of death. I really hope my dangerous demo doesn't work like this. Okay, so we're going to go here. Okay. So you gotta hand it to German security. They know their stuff. Okay, so this is what a CloudFormation template looks like. Okay, so it is, as you can see, this is a JSON version, which is humanly unreadable, unmaintainable. And what Amazon is trying to actually get to do is say, don't use this, use our template editor. So it's a kind of like a double-edged sword, because their template editor is fairly limited when you want to do really advanced stuff on one hand, and it kind of locks you into the Amazon environment. So you don't really know what's going on behind it. But as a general tool, it actually describes everything that you want to do in your stack. Great. So we created something that we call the CloudFormation tool. So one of the caveats of CloudFormation, as is on Amazon, is it doesn't support any type of inclusion files. It also doesn't have any syntax compiler that says, yeah, that CloudFormation makes sense or not. You just upload it, and hopefully it will not break. So we've basically about 6 months, no, almost 8 months ago, when we started migrating our existing Cloudonics platform from its original birthplace in DigitalOcean over to Amazon, we said to ourselves, we need something a bit more scalable in order to maintain it, so we came up with CloudFormation tool. CloudFormation tool, what it does, we actively maintain, but it's released through GPL2, so you can find it on GitHub, and it's Ruby-based, so we welcome pull requests if you're wondering in that case. So how does it work? So effectively what we have, wow, that looks bad. We have what we call the zone parameters YAML file. The idea is that we will define various aspects of our entire stack in here. For example, what type of instances we want to use, sizing, the various AMI images. And the most important part is actually here, is this little part. So the nice thing is that you can actually define how your stack is built at the network layer. You can actually define your various subnets and what is defined, what is enabled, what is disabled. And when you build a stack, or when you build multiple stacks, for example, if you're going to have a service spanning multiple zones around the world, uniformity is really important. You need to be able to say, okay, that stack will have the following first octet saying, okay, the VPC is 172.31 for that zone, and the next one is 30, but all the rest of the subnets are always identical. That's really important. Sorry. Another tool that we introduced is the ability to go about and say, okay, so I have a stack which is defined, and I already said that using IP numbers is bad and we want to use DNS, right? But the thing is that DNS cannot exist before the host exists, right? It's kind of like a mutually exclusive thing. They're synchronous to one another. So we created another open source project called Lambda Route 53 Updates. So effectively, you can actually call a Lambda function inside AWS itself. As your host is being spun up, it will automatically define its DNS domain name. So this is really good, for example, if you want to create a cluster of, let's say, Kamailio servers or a single SRV record for everything. So you can use that, and I'll show you an example how it's done. Again, actively maintained, and it is a GPL version 2 release. So how does it work? Inside our zone parameters, we will simply define this. By the way, you don't really need to download it. What I'm going to show you right now is actually how it's being done. So it works like this. I actually, where's the mouse? Oh, here we go. Yeah. Here we go. So basically, we tell it where the URL of our jar file is, and it's publicly available from GitHub. You put into your zone parameter files your DNS zone ID that you've defined inside Amazon. This is the only thing you need to do inside Amazon prior to building your actual stack. Once you do that, inside your launch configuration, we actually go about and create a Lambda function. The Lambda function basically tells the route configuration all the information in order to create the DNS records. For in this case, we create a round-robin record and an SRV record. In this case, called AST, because I took a bunch of asterisk servers that I want to cluster together into one host, into one domain name. Once we have that in place, we have what we call the topics and the permissions. The topic basically tells Amazon, okay, this is how I would like to activate my Lambda function and at what point in the execution of my auto-scaling group. And the invocation permission, of course. And of course, what we have the cycle in and cycle out. Cycle in and cycle out mean basically when your host goes up, it's a cycle in. When your host terminates, it's a cycle out. Basically, take that host out of the DNS. You'll be able to maintain this way if you're working inside auto-scaling group. This will make sure that your auto-scale group domain name is always updated correctly. It will always make sure that whatever you do is always uniformed. Unlike the CloudFormation tool, which is extremely tested and debugged, the Route 53 is still under heavy development, which means, yes, it's buggy and it's a little clunky at times, but we do welcome contributions to that one. It's Java-based, so you can go into the code and we'll be very happy to accept contributions for it. Sorry. So the good, the bad, and the downright ugly of using clouds. Anybody know, can give me a few reasons? What's the good and the bad of using clouds?
Bad is vendor lock.
Vendor lock. That is a serious bad. That is true, but you can avoid that if you work smart.
Not, for example, at Amazon, because they're forcing you to use some kind of the Amazon stuff that you can not easily move, for example, to Google Cloud.
That's entirely up to you. If you're talking about tools like CloudFormation, so Azure has their own stuff that you can use, and Google Cloud has its own orchestration environment, but I'm doing a demo according to Amazon because this is what we use. But you're welcome to look into each of these infrastructure. Each one of them has their own orchestration environment, so you can easily, let's say, mimic or duplicate the CloudFormation concept. That's one hand. But if you use cloud init files, and these are standard to everything, because effectively they all use some variant of either OpenStack or KVM. So the cloud init infrastructure will remain the same. So if you put everything inside cloud init, it will stay, and you'll be able to migrate from one cloud to the other. So the good is click-based scalability, auto-scalability, well-structured budgeting. If you work within the construct of your cloud and you plan it really well, you can get up to 75% savings on your infrastructure, and that is a lot. Large community support. The number of community members around the world that support the various clouds is astonishing. I think that regardless of what question you'll put on Google, you'll find it on Stack Overflow. You'll never find it inside the Amazon forums or user groups because everything is on Stack Overflow. High level of service assurance. Their services are extremely stable.
Half a minute.
Yeah, I know. And if you're willing to pay for it, then you get a higher level. Of course, enhanced scaling, better architecture options, and upgrades and updates are easily performed. The bad, as we know, requires an ops paradigm shift because normal ops people are not familiar with this. Ops are no longer sysadmins, they're developers. They should be thinking differently. Possible cloud vendor locking, as you mentioned. Not simple to implement at first. Takes about a month or two to get around the idea of using tools like CloudFormation and so on. May lengthen your initial deployment. So you should, if you plan the 6 months deployment, please add at least 2 more months in order to get this done the right way, depending on your platform. Sorry. May introduce some technical debts along the way, depending on what your platform is and how you developed it. And upgrades and updates must be tested and verified over and over and over again before you deploy them into your stack, because they may break your stack if you're doing it wrong. Questions?
I think not much time for question. You had the interactive and catch near, because it's a lot of useful information, because we're going to have also lunch, and I understood that we have like 12 participants to Dangerous Demo, so catch near around and let James present what's coming up. Or maybe one question, someone that if he says it quickly here, okay.
Really short word because we haven't got much time. Quas. And a complete absence of network control there. On your pros and cons, short word quas. You've got no control of the network whatsoever.
I don't really care. When you're in the cloud, your usage of the network is something that you don't need to rely on as something that you want control of. The minute you understand that you don't have that control, you need to design your platform in such a way where that control is meaningless. You're referring to control, I want to be able to control my summit, I want to be able to control my IP addresses, I want to be able to control my load balancers.
I'm referring to service assurance that RTP packets are going to arrive in full, on time.
Looks like long discussion outside. But okay, James, here.
Right.